Okay, I'm experimenting with different mic placements, so maybe you'll be able to hear me a little bit better. Okay. We are now doing sixth example. All right, so we're going to have the t derivative of u plus the x derivative of u plus u is equal to e to the x plus 2t. Now, and then finally u equals 0 on the x-axis. I want to only have the t derivative of u and the x derivative of u on the left-hand side and everything else on the right-hand side. So I'm going to subtract off u. So it's going to be this, like that. Okay. So the parameterization for gamma, again, x naught is 0. For x naught in the real numbers. The x prime, that's going to be whatever is multiplying the x derivative of u, that's 1. The t prime, that's whatever is multiplying the t derivative of u, that's 1. Z prime, that's going to be the left-hand side, okay? So it's minus u plus this, so this will be minus z. Remember, u is equal to z on the characteristics. Z of s is equal to u of x of s, so that's what we mean here. And then plus e to the x plus 2t. Okay, x of 0 is equal to whatever that is there, that's x naught. T of 0 is equal to whatever that is there, that which is 0. And z of 0 is whatever the function is there evaluated at that point, but here we're 0 everywhere. Okay, so if this equation was not homogeneous, the solution would be 0. But it's homogeneous. In other words, this term right there is the non-homogeneous term. All right, so this is x, this is t. Again, we can, not again, but similar to other problems, we can solve the characteristics pretty easily. X of s is equal to s plus x naught. T of s is equal to s. So these are going to be characteristics that are lines with a slope 1. Now we need to do a little work. I shouldn't have drawn this yet, actually, because I'm going to have to, solving the z differential equation is a little bit longer than it has been before, but we have z prime. Z prime, I'm going to write it as z prime plus z equals e to the x plus 2t, and we know z of 0 is equal to 0. Okay, now I don't need x plus 2t there. It can be confusing because oftentimes x and t are independent variables, but remember s is the independent variable. So I need to write these in terms of s. So x is s plus x naught, t is s. So altogether this is 3s plus x naught. And so now we have a non-homogeneous equation in one variable, a non-homogeneous ordinary differential equation. Pause for a moment and remind yourself how to solve problems like this. There's two ways we can think about it. The way that it is typically introduced in a standard differential equations class is using the method of integrating factors. If we think more holistically, we can use we can solve the corresponding homogeneous equation, that is that equation, and then find a particular solution to this equation using something like variation of parameters. It doesn't matter. Whichever way you want to do it is fine. I'm going to do the just integrating factors just because I think that's going to be the most straightforward. So remember, we multiply both sides of the equation by e to the antiderivative of the coefficient. The antiderivative of the coefficient, well, the coefficient is 1, so the antiderivative is going to be s. And when you multiply the left-hand side by e to the s, so if you multiply the left-hand side by e to the s, it becomes this right here. It becomes the derivative of z times e to the s, using the product rule. And if I multiply the left-hand side by that, I need to multiply the right-hand side, so we're going to get e to the 4s plus, actually, That is not right at all. No, it's not how I want to do it. So we're going to get, let me slow down here a little bit before I make any more embarrassing algebra mistakes. So this is what we get, and then we can add the exponents together, and we get e to the 4s plus x naught. Okay. So now what we're going to do is we're going to take the antiderivative of both sides of this. When you take the antiderivative on the left-hand side, the derivative just goes away. And so we've got z of s, z of s times e to the s. Okay, now when I do the antiderivative over here, here's what I was trying to do earlier. It might be a little bit easier to write it as e to the x naught, e to the 4s. E to the x naught is a constant, so we're going to have e to the x naught divided by 4 times e to the 4s plus a. Okay, now let's just figure out what a is using our initial condition. We'll solve for z in just a moment, but let's figure out what a is using our initial condition. So we're going to plug in s equals 0. On the left-hand side, we're going to get 0. On the right-hand side, when we plug in s equals 0, we're just going to get e to the x naught over 4 plus a, and so a equals equals minus e to the x naught over 4. So I'm going to go ahead and make that replacement. This is minus e to the x naught over 4. Okay. Then I'm going to divide both sides by e to the s. So the way that comes over here, this will be 3s, and this will be e to the minus s, like that. Okay. Let me just make sure that I have not done anything too wrong yet. Because there's a lot of arithmetic, and I'm not always going to be the best at that. Okay, there's a typo in the notes. In the notes, there's a 3 there, but it should be a 4. Okay, so that's what z of s is equal to. Okay, and so let me record that up here. So z of s is equal to e to the x naught over 4 times e to the 3s minus e to the minus s. Okay. Let me make sure I copied that down correctly. All right. So now, what we get is something like this. This is x, this is t. The characteristics are going to be the characteristics like this. Okay, these are just characteristics of slope 1. So if we have a generic point here, xt, we want to solve the, well, we know that u at that point is going to be given by this formula there, but we need to figure out what s and x naught are in terms of x and t. Well, we have x is equal to s plus s naught, x naught, t is equal to s, so this is t plus x naught, so x naught is equal to x minus t, and s is equal to t. And then so what we have is u of xt is equal to e to the x naught, which is x minus t, over 4 times e to the 3t minus e to the minus t. Okay, and again, you can verify that this differential equation does in fact solve this over here. You know, for example, well, I'll just let you figure that out on your own. Okay, that is it for this video.